Welcome back, everybody. I intend on these lessons to be done once a day, as though you were in class. Obviously, how often you do them is up to you, depending on your personal schedule and, how much you love math. But that is my goal, and as such, I will structure it the same way that I do in classroom and have a quick little refresh of what we did yesterday or a previous concept that is important. I learned a couple things from my first video, the last one. First thing is that I got to work on my handwriting, and I'm trying something slightly different here. So hopefully it works out a little better. The second thing is that I learned my family is a pain in the butt, that they like to wait until I hit record before they start doing anything noisy. So I'm currently hiding in my basement, hoping that they don't find me. Anyways, onwards and upwards. Today is a new day. So hopefully you remember the rules from yesterday. Give the first three questions a shot. So when we have a division, we subtract. When we have multiplication, we add. And when it's a bunch of different things like this, we treat each thing, we work with each thing individually. So 2 times -5 is -10. A squared times A, remember, it's even though it's not written, it's to the exponent of 1. So we dagnet it. So 2 plus 1 is 3. And likewise with that B, it's to the exponent 1. So we're good. Now, multiplication rules work all the time. You can multiply and divide any point, addition, subtraction. There are a few more restrictions on it, so we'll deal with that when we get to it. Just like yesterday's work, this is originally intended to be groups of 3. We'll go through the first one right now, and then I will come back at the end of the lesson for anybody who did the other 2. But I think you'll get the gist of things without me doing anything. So what do we notice from this? Of course, everything is equal. But why is it equal? Yesterday we looked at rules. When you multiplied, you added the exponents. When you divide, you subtracted the exponents. What is the rule here? So the first one we had 2 to the power of 3, and then all of that taken to the power of 2. And then the final answer is power of 6. Second one, we have power of 2, power of 2. Final one's power of 4. Last one is power of 4, power of 1. Final one is power of 4. So how are they related? When we have a power, and that's what we're looking at in these things, 0.1 to the power of 3, all of that to the power of 2, power of a power, we multiply the exponents. So with that in mind, try these. Now, the last one's a little tricky. Because really what we're doing is we're taking everything to the power of 2. So it ends up working out to 2 to the power of 2, a to the power of 2, and b to the power of 8. And there's 2 ways of thinking of this. The first is that it's really 2 to the power of 1, so when we multiply the exponents, it's 2, just like it is for the a. We can also think of it this way, and this is the reason that the multiplication rule works. That little squared symbol means we're taking 2ab to the 4 and multiplying it by 2ab to the 4. And notice that if we were to use our rules, 2 times 2 would, using the exponent rules we used yesterday, right, the multiplication rules, add the exponents of 1 and 1 to get 2 to the power of 2. A times A using our exponent rules because it's A squared, and B to the power 4 times B to the power 4 gives us B to the power of 8. So we're actually using the multiplication rule from yesterday, but we're using a shortcut to do it. Now, we wouldn't leave the 2 to the power of 2 that way. We are able to solve that, so let's solve it. The rest of them, unfortunately, we cannot do. There's nothing we can do with A squared. There's nothing we can do with the B to the power of 8. So they just get rewritten out exactly the way they are. All right, so the last little bit, we have some slightly more complicated functions going on here. How do they all combine? Remember, BEDMAS rules apply. Always, 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 BEDMAS, BEDMAS, BEDMAS. Okay, so give it a go. And here are the solutions. Numbers times the number, u times the u, v times the v. Remember that u, even though there's no exponent written, the exponent is 1, which is why 1 plus 2, that's where the 3 comes from. Oh, shoot, I'm forgetting my BEDMAS. Now remember, everything gets to the power of 2. Now notice that that negative sign is also inside the bracket, so it's getting squared as well. So negative 4 times negative 4 is positive 16. So 8 divided by 16, that's 1/2 or 0.5. U squared divided by u squared. Anything divided by itself is 1, I'm sorry, is 1. And then that is a really bad 6 divided by u to the 4 equals u squared. Yeah. Okay, and that last one, again, remembering BEDMAS, I can do two things at once. So negative 2 times negative 8, negative 16, u to the 3, v to the 5. Again, that negative sign is inside the bracket, so it makes it a positive 16. And divided out, negative 16 divided by 16 is negative 1. I don't have to write the 1. It's just assume that it's there. Ooh, negative UV. I guess UV is bad. Yeah. So to recap, anytime you have a power of a power, it means that you are multiplying the exponents. So in human terms, I don't know, 7 to the power of 3 to the power of 9 means we're really doing what's 9 times 3? Oh, 27. All right. So there's your homework there. And for anybody who did a different value, I'm going to go back and finish off those questions. Okay, that's it. Have a good one.